Hello and welcome to Vishwa Shanti Darshan, where the programming focuses on world peace, spirituality and science. The channel was commissioned by Vishwadharmi Professor Dr Vishwanath Dakarar, who has devoted his entire life in pursuit of world peace. We know about the dinosaurs, but what about the world they inhabited? A world dominated by plants so strange, so bizarre, that they seem like science fiction. Yet, they were real. Welcome to the world of prehistoric plants. This fossilized specimen wasn't a tree. It wasn't even a plant in the way we understand them. For over a century, scientists debated what was Prototaxites. Prototaxites, a mysterious giant organism from the Devonian period, has puzzled scientists for decades. By comparing its carbon isotope ratios with modern plants, researchers discovered that prototaxites don't fit the photosynthetic profile of C3 or C4 plants. Instead, its intermediate values suggest it was more likely a fungus or heterotroph, feeding on organic matter. This finding reshapes our understanding of early terrestrial ecosystems, showing that ancient landscapes were home to diverse life strategies beyond photosynthesis. When these were first discovered, everyone was baffled. 24 feet tall, but no leaves, no roots, no branches. Some thought they were giant mushrooms. Others believed they were strange trees. The debate lasted decades. The breakthrough came from analyzing chemical signatures. The evidence pointed to something incredible. The chemistry doesn't lie. Prototaxites was indeed a fungus, but unlike anything alive today. A fungal tower that dominated the landscape for millions of years before trees even evolved. If prototaxites were strange, wait until you meet the scale trees. This diamond pattern isn't artificial. It's the skin of the Lepidodendron, and these plants rewrote the rules of what trees could be. The scale trees could grow over 150 feet tall, but they had a completely different architecture from modern trees. Their entire growth strategy was alien to us, and when they reproduced, they died. Global synchronized death events. Today, flowers are everywhere, but 140 million years ago when they first appeared, they were strange. Darwin called the origin of flowers an abominable mystery because the sudden appearance of diverse flowering plants, the angiosperms in the fossil record, seemed to contradict the gradual nature of evolution he proposed. There was a lack of intermediate fossil forms, and the rapid diversification and dominance of angiosperms in the Cretaceous period were inexplicable based on the evidence available in his time. This rapid emergence was particularly troubling because it seemed to be a case against his theory of gradualism. The first flowers weren't showy or colorful. They were small, weird-looking structures. We have fossils showing flowers that look nothing like their modern descendants, arrangements of parts that seem wrong to our eyes. The ancestors of flowering plants diverged from gymnosperms about 350 million years ago. They have small xylem, a solitary flower with long reticle and leaves converted into petals. Anther is long and flat leaf-like. In the early stage, pollens are dispersed by wind. The evolution of the first flowering plants, such as Ambarella, occurred at the beginning of the Cretaceous period. Plants that are found today, such as lotus plants and custard apple, show primitive characteristics similar to ancestors of flowering plants. These plants are believed that they have evolved and then separated into double cotyledon and monocotyledon. Recent discoveries have revealed exquisitely preserved early flowers frozen in time. What's truly remarkable is how quickly flowers diversified once they appeared. It was an evolutionary explosion that changed the planet forever, leading to partnerships with insects that reshaped entire ecosystems. Wings hum a hymn. Petals cradle gold. In this quiet pact, life unfolds. Imagine a plant that doesn't just thrive on sunlight and water, but also devours insects. Yes, carnivorous plants are real and they're spectacularly eerie. They have evolved in nutrient-poor environments where the soil is low in nitrogen to survive and grow. This alternative feeding strategy allows them to thrive in places where other plants would barely survive. First on the list is the iconic Venus flytrap. This plant lures insects with its nectar, then swiftly closes its leaves to trap the prey, initiating digestion. Next is the pitcher plant. They have evolved leaves that form deep cavities filled with digestive liquids. Insects, attracted by the plant's vibrant colors and sweet scent, slip on the pitcher's slippery inner surface, falling into the liquid where they are digested. Moving on to sundews, which possess sticky glandular tentacles. Once an insect is caught, nearby tentacles curl around it, securing the prey for digestion. Lastly, the bladderworts, which are aquatic or semi-aquatic. They use bladder-like traps to suck in tiny water-dwelling creatures. The discovery of a 47-million-year-old fly from the Messel pit in Germany with a stomach full of diverse pollen provided the first direct evidence that flies were significant pollinators in ancient subtropical ecosystems, challenging the assumption that bees and butterflies were always dominant. The evidence is subtle: hairs that could secrete digestive enzymes, structures that might have formed traps, insects preserved in positions suggesting they were caught. These plants were experimenting with carnivory much earlier than we thought. Sometimes the past survives. This tree was known only from fossils until 1994, when a living specimen was discovered in Australia, a genuine dinosaur-era tree hiding in plain sight. Discovering the Wollemi pine was like finding a living dinosaur. The genetic evidence shows that these trees have remained virtually unchanged for 200 million years. They saw the dinosaurs come and go. These strange plants aren't just curiosities. They built our world. They created the atmosphere we breathe, the soils we farm, the fuels that power our civilization. The story of prehistoric plants reminds us that evolution experiments, that what seems permanent can vanish, and that the most ordinary leaf outside your window has ancestors that would seem utterly alien. The fossils records show us that in the world of plants, truth will always be stranger than fiction. Our ancestors knew these plants before they were fossils. Stories tell of the ghost forest plants that remember when mountains were flat. Science is just catching up. These living fossils aren't curiosities. They are libraries of resilience. weren't just plants. They were planetary architects. The air we breathe, their recipe. The soil we farm, their remains. The coal that powered our revolution, their buried bodies. Even the colors we see, flowers invented them. We stand on a world built by these strange, wonderful beings. And now, in a single human lifetime, we are unraveling what they built over millions of years. Paleobotany isn't about the past. It's a message from deep time. These plants survived asteroid impacts, ice ages, continental collisions. They adapted in ways we are only beginning to understand. Now their descendants, our forests, our crops, our oxygen makers, face a changed world once again. But this time, we are the asteroid. Their story shows that life is stubborn. It finds a way. But it also shows that worlds can end. The question paleobotany leaves us with isn't what was, it's what will be, and whether we'll be smart enough to learn from plants that outlived the dinosaurs.